Alright, so for the first question I'm going to discuss, it's question 2 of multiple choice, and it's asking for the inverse. So first of all, we have to understand that the graph has a domain of, a range of R plus. So y is R plus. And then to find f inverse, for f inverse of x, let f of y equal x. So that means we interchange x and y. So x is equal to 1 on square root of y plus 2. If we rearrange, we get 1 on x is equal to square root of y plus 2. And then we get y is equal to 1 on x squared minus 2. And for the inverse of a function, the range of the original function, so that's here, will be the domain of the inverse, so that's here. And here we got the inverse, so we can get A. I think the next question is question 3. Question 3 is pretty tricky. So most of us would immediately go A, just because of the nature of how we find these types of graphs. But it's actually kind of a trick question, because so here we've got b is a negative value, so b is less than 0. So if I made, let's say b is negative 2, then the graph, if I left it as a, in the form of a, it would be y is equal to negative 2, x minus 2, and then if c and d are also positive, let's say c is 1 and d is 2, it would be x minus 1 squared and x minus 2 squared, x minus 2. And as you can see, all of these would make a positive x-intercept. So actually, what is actually happening is we need to get, because b is negative, so that means we have to sort of negate the negative by putting another negative in front of it to cancel it out. So that's what happens here, over here. So for the next question, is question 8. Again, this is pretty simple. So obviously, if the x value is the same as the y value, and it's a straight line, we're told it's a straight line, then it's just y is equal to x. And at this point, we can figure out this is also a triangle. So the average value of the function from this whole domain is 0, so that means this area has to cancel out this area. So basically this area here has to equal this area. So basically half times p, so base times height, will equal this, 25 on 8. So half p squared is equal to 25 on 8, p squared is equal to 25 on 4, p is equal to 5 on 2. So that's D. Next question, question 9. So here we can just to figure out what value A is, we can go from integration from 2 to A of 1 6 dx is equal to 1. We get A is equal to 8. And when you go from 2 to 8, and to find the expected value, we just times the function by x, so x divided by 6 dx, and then we get that is equal to 5. So the expected value is 5.
I don't think they understood x divided by 6. You just straight away put x divided by 6.
So basically what I did was, so the function is equal to 1 divided by 6, because it's just a straight line. And when we want to find the expected value of x, e of x, it's equal to negative infinity x times f of x dx. I don't know if you can read that, my bad. So what I did was just times x times 1 and 6. So that's the same as x divided by 6. And when you integrate this function, you get 5. So that the expected value is 5. Next question, question 11. So you're trying to turn this graph into the form of this. So basically what you do is you can rewrite this as 8 times x divided by 2 whole thing cubed plus 1. So as you can see, if you expand that out, you get x cubed divided by 8 plus 1, so the 8's cancel out and you just get this. So basically what happened here was x divided by 2, x dash divided by 2 is sorry, yeah, so x dash divided by 2 is equal to x using the transformation notation. So that means x dash is equal to 2x, and that means that it's a dilation of 2 from the y-axis.
Okay, so there what you have to understand, he's just getting the answer in a few seconds, right? What is the construction you need to understand? The construction is that 8x divided by 2 to the power n. That is what you have to understand. If you have that construction, you can match with that and then 8 is gone, right? That's what he's saying, right? You understand the message? That is what you have to use when you are rectifying it.
Okay, so this you can construct a tree diagram. I'm pretty sure there is a way of doing it binomially, but I'm not going to do that for now. So you can do red or blue. And the key hint to doing this question quickly is that at least one of the balls selected is red, right? So that means every single option here will have red except for this row here. So that means what I can do is find the probability of just this line. So here, if the probability of red is 5 out of 8 and the probability of blue is 3 out of 8. So without replacement means that when you take a ball out, that means there's going to be less balls in the box after. So it'd be 2 out of 7 and then 1 out of 6. So that means the total probability of finding a ball that is red is just 1 minus this probability here. So that's just 1 minus 3 on 8 times 2 on 7 times 1 on 6. And that gives you 55 on 56.
Okay. So in this question, it's without replacing, right? Can you do this in binomial? You can't. Binomial is not defined. If you want to do this in the binomial, you have to involve the matrices.
Yeah.
Right? Like in the long term probability. So these kind of questions definitely is tree diagram. Binomial you can't use. So,
Okay, next question.
Have that as a fact, right?
Is question 13. Basically pretty simple here. So that means all you have to do is the integration from 0 to 1 of this function. I just took the a out as it's a constant. Dx plus the integration of this from this domain, so from 1 to 2 of e dx is equal to 1. So I can take the a out as a factor, and it would just be e to the power 1 minus e to the power 0, which is 1, plus actually I'll just expand this out a bit. So it becomes e to the x from 0 to 1 plus e times x from 1 to 2. So that becomes e to the 1 minus 1 plus 2e minus e. So 2e minus 1. And yeah, that gives you e. Everyone understand that, right? This one, everyone understand? Yeah. Question 14. So first of all, we have to find the value of p. And to find the value of p, you just add these together and equate it to 1. So p plus 2p plus 3p plus 4p plus 5p is equal to 1. So you get p is equal to, I think, 1 on 15. And then to find the mean, which is e of x, again, it's just small x times capital X. So that's equal to 1. Oops. There you go. So that's 1 times p plus 2 times 2p plus 3 times 3p, so on. I think you can get the gist. And that turns out to be, and here you can sort of put in the calculus and say, given that p is equal to 1 on 15, and then you'll get, I think, d, is it? Yeah, d. So next question, question 15. Here you have to use the properties of integrals. So let's first of all rewrite this, splitting it up. So this is 2 times g of x dx plus 0 to 5 ax dx, and this whole thing is equal to 90. So here we can write this as 2 times 0 to 5 integration of gx dx plus, again, it's the same thing. And here we're given that 0 to 5 integration gx dx is equal to 20. So this is the same thing as 2 times 20 plus integration from 0 to 5 ax dx, which is equal to 90. So 0 to 5 ax dx is equal to 50. Ax squared on 2 from 0 to 5 is 50. 25 a on 2 minus is equal to 50. A is equal to 4. So that's B. Yeah. At question 16. So what I did was just simply simple different integration. So if f dash of x is an antiderivative of g of x, so let's find f dash of x. F dash of x is equal to m ax m minus 1, and the antiderivative of g of x, so integration b x to the power n dx, which is equal to b over n plus 1 x to the power n plus 1. So we can say that m ax m minus 1 is equal to b n plus 1 x to the power n plus 1. And here I can bring m to the other side, and sorry, yeah, so I can bring b divided by a. Actually, I can rewrite this over here. B divided by a is equal to m times n plus 1 x m minus 1 over n plus 1. N plus 1 cancels. M is an integer, so that means therefore b divided by a is an integer. If you sub like a random value, and you'll get that b divided by a is an integer.
Okay, you guys are watching like a movie this one. I know 90% you didn't understand what he did.
Actually, I want to rewrite this, and it's going to make it easier. I want to equate the coefficients. So ma is equal to b over n plus 1. That means m times n plus 1 is equal to b divided by a. Both m and n are positive integers. So that means this whole thing will be an integer, right? So that means b divided by a is an integer. I think that should be easy to understand.
Okay. Here is this for right hand side stuff, right?
Mm-hmm. So we're given f dash of x is an antiderivative of g of x. So I'm going to redo this whole thing. F dash of x is just the derivative of this. So you bring m to the front, ma times x to the power m minus 1. That's how derivatives work. And this would, so f dash of x would be equal to an antiderivative of g of x. And the antiderivative of g of x is equal to integration of b x to the power n dx. See how? Yeah, that's better. And that is equal to b divided by n plus 1 times x to the power n plus 1. So that means this is equal to this. So ma x to the power m minus 1 is equal to this. So we can equate these coefficients. Actually, what? Sorry. Yeah. We can equate these coefficients. So ma is equal to this. If we were given these four options, so I wanted to try and find something that's close to this. So b divided by a is equal to m times n plus 1. And then m and n are integers. So let's say m is 3 and n is 2. 3 times 2 plus 1 is just 9. So that's an integer as well. So b divided by a is an integer. Is that better? So next question, question 19. Here I put it in the CAS. So what I did was in the CAS I put d dx of this integral for, and then you get, I think, yeah, you get this. And then here I just said given that x is equal to negative 2 from here, so that's just putting x is equal to negative 2 inside. And then you get 2 root 2. Okay, question 21. So to find points of intersection, let's just make these two equal to each other. mx plus c is equal to ax squared. So ax squared minus mx plus c is equal to 0. And we can recognize that this is a quadratic. So that means if you want to find no points of intersections, there should be no solutions to this quadratic. So that means discriminant must be less than 0. So discriminant is b squared minus 4ac. Here b is m minus m. So b squared is m squared minus 4 times a times c. And that has to be less than 0. We're looking for something in terms of c. So 4ac is greater than m squared. C is greater than m squared on 4a. And when c is greater than, sorry, that should be negative. So when c is greater than minus m squared on 4a, I think the only option you can get by the answers is when a is less than 0. I think there's a way to show this graphically. Yeah, okay. The best way to show it is when a is greater than 0. Yeah, so when a is greater than 0, c has to be less than minus m squared on 4a. When a is less than 0, c is greater than minus m squared on 4a. And the only option that satisfies both of these conditions is D. So that's just coming from the CAS. I think that's all the multiple choice done, because this is mod. So now on to short answer.
Wait, can you do question 10?
I'm not gonna lie, question 10 I didn't do properly as well. Is there a way to do it? So 2 is equal to NP, and n 4 on 3 is equal to np1 minus p. I'll put that in the CAS and simultaneously solve them. Oh, okay, yeah, I got that just there. So n is 6, p is 1 divided by 3. So then you just put that in the CAS and should be mainly.
Probability x is equal to 1 is equal to 6c1 p1 1 minus p5.
Okay. Oh yeah, x is equal to 1 is equal to 6c1 1 third 1 third. Oh, why not? 2 thirds. Yeah, so that's 6 times 1 third times 2 thirds to the power 5, which is D. Vish, you got that?
Yeah, I just put it there.
Okay, cool. Is that it?
Yeah.
For multiple choice? So, how do you... Okay, on to question 4 of the short answer. So what I did was, I recognized that these two areas are equal, so that means it's symmetrical. So that means 2 times integration from 0 to pi, so this of the top function, so that's, top function is f of x minus g of x is equal to, so without the 2, that's just this area I found, and then I multiplied by 2 to find these, should be equal to a times 0 to pi sine x dx. I just solved that on the CAS and I get a is equal to 4. Okay, so just simply graphing should look something so just make sure your turning points and x-axis intercepts match with the lines. State a sequence of 2 transformations, so h of x is 1 third sine 3x. So y and we're trying to make it equal to 2 sine x. So then when you, sorry, okay, so when you rearrange for y dash and x dash, you get y dash is equal to y divided by 6 and x dash is equal to x divided by 3. So that means we've got a dilation of 1/6 from x-axis and dilation of 1/3 from y-axis, from these two. That's when we map this onto this. So here, this one is pretty tricky. So what I did was, to find the area, I just used this on the CAS. 2 times 0 to pi m sine x, so top function minus bottom function, minus 1 on n sine n x dx, and you get something on the CAS that looks like 4m plus 2 cos n pi over n squared plus 2 on n squared. And here n is even, so when n is even, cos n pi will always equal 1, no matter what number. So cos 2 pi or 4 pi will always equal 1. So that means this whole thing will, sorry, not 1, negative 1. So that means this whole thing will just equal negative 2 on n squared. So then this will cancel out with this, and so you just get 4m, and if you write it in the form of this, it's just 0 divided by n squared. Same thing here, I just use the same formula here, and you get again 4m plus 2 cos n pi divided by n squared plus 2 on n squared. Here n is odd, so cos n pi is always equal to 1. Cos 3 pi is always equal to 1. Wait. Shadman, am I tripping?
What?
Is cos n pi 1 or 1, negative 1?
Cos what? N pi?
If it's odd, if n is odd.
It would be negative.
It's negative 1, right? Cos n pi if n is odd.
That should be negative.
Yeah. Yeah, so this should... Sorry, let me just rewrite this. Yeah. Sorry. Okay, so here cos n pi is actually 1, so this would cancel out and become 0, so then you get this. Here cos n pi is negative 1 because n is odd, so then you get 4m plus 2 negative 2n squared minus 2n squared. So you get 4m plus negative 4n squared. Okay, yeah. Plus 4 on n squared. So here I'm just going to quickly draw the graphs. So here we can sort of match these functions to this and this. So obviously m as an amplitude will be greater than 1 if m is positive, and 1 divided by n will also be smaller. So I could say this would be q of x and this would be k of x. You get that? Yeah? For A. Does it make sense? You just put in the CAS and then you solve.
Is it integrating the whole thing, like mx and g?
So it looks like you get it? Yeah. Okay. Question 5. So simply I just defined this on the CAS. S of 0 is 10, S of 5 is 2e 5 on 3 plus 8e minus 10 on 3. The minimum value is happening when t is equal to log EC. So I just found s dash of t. So that's 2e t on 3 divided by 3 minus 16e minus 2t on 3 divided by 3. And you want to make this equal to 0. So you want to make the derivative equal to 0 for the minimum. T is equal to 3 ln 2 when you solve this on the CAS. And you can absorb the 3 inside to 2 ln to the power 3. So that's ln 8. So that means C is equal to 8 and S of ln 8 is equal to 6. So therefore minimum value is 6. When you graph this, it's from 0 to 5. With the CAS, you can equate these numbers. I think this was like 10.8, around 10.87. And I think ln 8 was around 2.3. So, yeah, around 2.3. So, connect the dots. And just label your endpoints.
Yeah, that's a curve.
5, 2e.
Literally drew a straight line. I don't know how you did that.
So that's the graph. Find the average rate of change for a function s over the interval. So we already know that s of 0 is 10, s of ln 8, ln c is 8, c is 8, so it's ln 8. So ln 8 is 6. So then average rate of change is just 6 minus 10 over ln 8 minus 0. That's just the average rate of change formula, so that's minus 4 on ln 8. If the minimum value of the function occurs at t ln 9, find the value of d. So find v dash of t. V dash of t is pretty big. d e t on 3 minus over 3, 2d minus 10 e to the power minus 2 on 3 divided by 3. For minimum, v dash of t equals 0, where t is equal to ln 9. You put this in the CAS, so the given that t is equal to ln 9, you get d, and you solve for d, and you get d is equal to 20 on 11. Find the set of possible values of d such that the minimum value of the function occurs when t is equal to 0. So that means v dash of 0 is equal to 0, and you solve for d on the CAS. D is equal to 20 on 3, and you have to catch that yeah, so this, you have to read the question properly. So the set of values, you're finding a set of possible values, and I think d is between 0 and 10, so that means d here would be between 20 on 3 and 10. Find the set of possible values of d such that the minimum value occurs when t is equal to 5. So v dash of 5 is equal to 0. You get d is equal to some number 20 on 2 plus e to the 5. Again, you have to consider the set of values, except this time it would be from 0 to that number. So it would be from 0 to 20 on, 0 to d to 20 on 2 plus e to the 5. Again, last question. So here the function has a local minimum at a, so v dash of a is equal to 0. So then you get, and you solve for d, you get d is equal to 20 on either a plus 2. I rearranged to find what a is. A is equal to ln minus 2d minus 10 over d. And then I just subbed that into v. So I could say x is equal to this as well. So v of ln d minus 10 over d, and you get this equation on the cas minus 2 d minus 10 1/3 over 2. You can take this 2r from here, so that's equal to 3, because you're trying to make it in the form of this. So 3 times 2 to the power 1/3 d 2/3 10 minus d over 2. And so here this number is equal to k. So k is equal to 3 times 2 to the power 1/3. That's it from me.